if the function f is defined by fx to be equals to x cubed minus k plus 1 x squared plus k plus 1 x minus k, where k is a positive constant. So given that x minus k is a factor of fx, we factorize fx completely. Okay, so there are a lot of ways to go about doing this. If you can either use comparing coefficient or use the long division method. So here I'm going to show probably the long division method, okay, which in my opinion is the it's not the fastest, but it's quite safe, okay, because it allows you to check if your answers are correct. So fx over here, right? If x minus k is a factor of fx, that means I can say that my fx, which is my dividend, but the division algorithm is x minus k multiplied by some quotient, added to some remainder. Okay, so this is me just applying the division algorithm where dividend is equals to divisor multiplied by quotient plus the remainder. Okay, plus the remainder. So in order to find my quotient, right, and my remainder, I will probably need to do long division. Okay, in this case, or I can do comparing coefficient. The fact that they tell you that x minus k is a factor, right? So it also tells you that there's no remainder. So the remainder is just equals to 0. Okay. So I'm just going to show you method 1 first. All right, so method 1 is basically by long division. Okay, which I will show you basically by long division. I take fx, which is x cubed, minus k plus 1 x squared, plus k plus 1x minus k. Now, even though this is very, very tedious because of the coefficients, right? Just do it slowly and you should be able to get the correct answer, okay? So I've compared, always remember when you do long division, always write the terms in decreasing powers from x cubed followed by x squared followed by x followed by constant. Okay, similarly for the divisor, always write it in decreasing powers. Always align the highest power to highest power when you are doing the cancellation. And our objective is always to knock out the highest power in each step. Okay, so just imagine if we are doing this, right? The first what we want to do is we want to get a so-called knock out the x squared. Then there's a cancellation, and then we want to x cube, sorry. Then we want to knock out there will be an x squared coming down. You want to knock out the x squared. There will be an x coming down. You want to knock out the x. Finally, you are left with a constant. Okay, unlike the numerical long division, algebraic long division, you may need to continue a few steps until the degree of the divisor is more than the degree of the remainder, because you cannot divide anymore. Okay, so from here, I compare x and x cubed. So I know that to knock out my x cubed, I will have to take x to multiply by x squared. Okay, so x over here, x squared multiplied by x, that gives me x cubed. X squared multiplied by k, that gives me negative kx. Okay, and remember we have put a bracket around. Okay, so if you are confused, right, then what you can do is you can also put the negative in this manner. Okay, so you can see that I purposely align my x and x terms together. And so you can see that x squared here, right, has nobody underneath. Okay, so with that, I rewrite my new expression. X cubed is knocked out, minus k plus 1 squared. Okay, k plus 1x minus k minus kx. So minus means that it will be a plus. Okay, minus will be a plus. Oh, sorry. Okay, because x squared times k, this one should be an x squared as well. Okay, this one should be an x squared as well. So let me just arrange this. Apologize, I'm doing this on the go as well. Okay, so this is minus kx squared. So this is a careless mistake I made here. Okay, x squared. Okay, so from here, instead of minus k plus 1x squared, minus k plus 1x squared, minus k. Okay, so there's a minus kx squared here. There's a plus. Okay, because minus when I give you a plus, overall, right, you will cancel off. Okay, also at the side, it's like I'm doing this, I'm doing this. There's a negative k plus 1x squared minus kx squared. Okay, so it's like negative kx squared, this portion, minus x squared, minus plus kx squared. So you can see it cancels off. I'm just left with a negative x squared. Okay, the rest of the terms which are not affected, I'm just going to rewrite them as per usual. And the next step, I observe that there's a negative x squared. Now I'm going to knock out this negative x squared. In order to knock this out, x must be multiplied by minus x to recreate a negative x squared here. Okay, so x and negative x will give you negative x squared. Negative k, negative x, that will give you a positive kx. Okay, again, bracket, and make sure that I minus this off. So from here, this cancels off. Okay, k plus 1x minus kx. Okay, so again, this is like k plus 1x minus positive of kx. Kx. So what you have is like kx plus x minus kx. You are just left with a x minus k. Okay, which is very ideal. X minus 1 multiplied by 1. That will give you another x minus k. And you can see that definitely the denominator, remainder should be 0. Okay, why is it 0? Because remember, it's a factor. It's a factor. Okay, so this is our quotient over here. This is our quotient over here. So that's the good thing about long division. When you get a factor as 0, you know that you have arrived at the correct answer. I mean, this is definitely a correct answer. So with that, right, we are done. So our fx, right, remember, based on this portion, right, is written as x minus k, x squared minus x plus 1. Okay, this is our answer. Okay, so when we look at x squared minus x plus 1, the fact is we cannot factorize this anymore. Sometimes you can in certain situations, but in this question you cannot, because this is non-factorizable. Okay, if you try to find a discriminant, we also find that the discriminant is less than 0. Okay, so we are done. Okay, so next, let's look at part 2. Now the graph, I'm just going to erase this part. Okay, so the graph of y equals to fx intersects the x and y axis at point A and B respectively. So find in terms of k, the area of AOB where O is the origin. Okay, so simple idea, if my fx at the x-axis, right, and at the x-axis, right, we are looking at point A, right, and at the y-axis where it intersects, right, you'll basically be point B. Okay, so if you want to find the point A at the x-axis, you just need to sub y equals to 0. Okay, so y equals to 0 means that fx equals to, I mean, now we have factorized it. If we sub this, y equals to 0 means we are subbing this to be 0, right? Then our answer is just either x equals to k, right, or x squared minus x plus 1 equals to 0. Now remember earlier, this, right, has no solution. This one has no solution. Okay, try using the calculator for this. You will find that you eventually can show that the discriminant less than 0. So there are no real roots for this. Okay, so the only solution is x equals to k. Okay, which means that if x equals to k, y equals to 0, your point A is just k comma 0. At the y-axis, to find point B, remember y-axis, the y-intercept, to find the y-axis, you sub x equals to 0. Okay, because on the y-axis, all the x coordinates are 0. So you sub x equals to 0, right? Then fx basically is f of 0. So you sub, okay, x minus k will be 0 minus k. X minus k, 0 minus k. 0 square, 0, 1. Okay, so you're adding 0 square minus 0 plus 1. That gives you negative k times 1, negative k. Okay, so again now, that means the y value is negative k, the x value is 0. So your point B is just 0, comma, negative K. Okay. What does it look like? Okay, because they tell you that K is a positive constant, so you just imagine that the graph will look something like that. So that means, okay, imagine if you don't want you to find triangle AOB, okay, K comma 0 will probably look something like this. Let's imagine that K is the number 3, right? So K comma 0 will look something like this because K is positive, okay? B comma B, which is 0, comma, negative K, the y-intercept looks something like this. 0 is the origin, so it looks something like this, okay? So I'm asked to find the area of this triangle. Not too difficult, okay? You can see that this is K units long. The height is also K unit long. Okay. So the area of triangle AOB, like all you need to do, you just take half times base multiplied by height. That will give you half K square. Now there's no unit for coordinate geometry, so we just put it as a unit square. Okay, and then we are done.